I'm now going to be talking about interpreting the results of box whisker plots after you've created them. I'm assuming that you have already watched the other video on how to create them. So this will be after that. If we look at our typical distributions, the first one being a nice uniform distribution, what I'm going to do is I'm going to draw a box whisker plot that is representative up above it. So here's what the box whisker plot might look like. That matches a nice uniform distribution. Some qualities here is that the length of the whisker is actually pretty much the same length as from the median to Q3. From the median to Q1 is actually that same distance, and the last whisker is also the same distance. So this is all really, these segments are all the same distance, because if you think about it, we have a nice uniform distribution of data, then the quarter points are going to be evenly distributed as well. Now our next distribution, which will be a little bit different, is symmetric distribution. This is going to look a little different than that because, of course, a lot of data is concentrated towards the middle. The box whisker plot is going to look a little bit more like this. And you can see, because this is a symmetric distribution, the median will be in the middle. And because there's a lot of data in the middle, it doesn't take very long to get to the quarter, both the first and third quarter points. So they're actually fairly close to the median. And then these whiskers proportionally are longer than this distance between median and quartile. The whisker is actually longer, because these tend to, trail off, and the maximum and minimum are farther out than the quarter points from the middle. So you get the long whiskers, in this symmetric distribution. An alternative to this particular symmetric distribution is another kind of symmetry. Something like this. This is a bimodal of it's almost the antithesis of this kind of symmetry. And let's look to see what the box whisker plot might look like for this one. Box whisker looks something like this, which is quite different than the one above it. Here, because the data is concentrated at the extremes, from the median, which is again isn't going to be the middle because it's still approximately symmetric distribution, median will be in the middle, it's going to take much farther to get to the first and third quartiles, but then not very much distance to get the last quarter. So we're going to have short little stubby whiskers and a really long interquartile range. That's the box. One thing to kind of come away from this is that the relative size of the whiskers versus the box tells you something about the data density. That we have the same percentage of data in actually both of these portions. If you think we're cutting the data into quarters, so 25% of the data is here, 25% is here, 25 is here, and 25 is here. So it's the same amount of data approximately, but this is over a longer range. So the density of data is a little bit lower, which you can see as being shorter and smaller frequencies. Essentially more frequency bars that are shorter. And over here, this is also 25% of the data, but it's over a shorter period of time, so that has to be accomplished with greater frequencies of similar data. So that's an important thing to come away from. Let's talk about a couple of others. So here we have two classic examples of skewed right and skewed left. We can look to see what these box whisker plots are going to look like. You can actually even pause the video and see if you could predict what they might look like and then compare. So here's what the box whisker plots look like. You'll notice if we look at the histogram, the data is concentrated over at this end. So this is going to have shorter segments. This whisker is going to be short. It's going to get progressively longer because it's getting stretched out as we go up. So this is the shortest piece from first quartile to median, it's going to get a little bit longer. From median to third quartile, it'll stretch out a little bit more. And then the last whisker will be the longest segment. And of course, skewed left just reverses the direction of all that. The last thing we can talk about is what happens if we have some extreme values. We can look at some examples like this. So here's a fairly typical, nice symmetric distribution. What happens? Well, let's look at the typical box whisker plot for this one. So here's the classic shorter box, longer whiskers, this nice symmetric distribution. Well, what happens if there's some extreme value that just pops up way out over here? Now, is that going to really affect the median all that much? Well, probably not. It may not actually change it at all. And it probably won't affect the quartiles really that much either. But what it does affect is this maximum point. All of a sudden, it's going to just jump all the way over to this new maximum. So we get this really extraordinarily long whisker. So when you see something like that, that's probably an example of some extreme data point that's in your data set. We're actually going to be able to get quantitative about how to identify extreme data points called outliers. But at this point in time, you see something, one portion, especially one whisker, that's really out of proportion to an extreme extent. That's probably an indication that there's an extreme data value. Of course, here's another nice symmetric distribution. What would happen if we don't have just one extreme data value, but maybe we have some symmetric extreme data values? Well, it would look something kind of like this, where again, so proportionally, this distance and this distance, this is like way, way, way longer than this interquartile range distance. And that's alerting you to the fact that there's probably some extreme values.